I will continue the discussion about Chapter 2, Basic Laws. So this time, the topic will be series resistors and voltage division. Consider the single loop circuit of figure 2.29. So there's a kilid on the right side. The two resistors are in series. So R1 and R2. Since the same current flows in both of them, okay, so series sila since they have the same current nga nag-agi sa resistor. Applying Ohm's law to each of the resistor, we obtain V sub 1 equal to I R sub 1 and V sub 2 current times R sub 2. So makita man na sa figure 2.29. If we apply KVL to the loop, moving in the clockwise direction, we have negative V, which is the source, plus V sub 1 plus V sub 2 equal to 0. And then, continuation diri sa right side, voltage source is equal to V sub 1 plus V sub 2 equal to current times the total resistance. So, total resistance will be R1 plus R2. Okay, since naka-series ang mga resistor. Therefore, current is just equal to voltage V, which is the source, divided by R1 plus R2. So that would be the equation for the current in the given circuit in figure 2.29, a single loop circuit with two resistors in series. It can be written as voltage equal to current times equivalent resistance. So kung i-sum up to tanan mga resistor nga given, so ang tawag is equivalent resistance, implying that the two resistors can be replaced by an equivalent resistor or mga tawag nga R, EQ or equivalent resistance. That is, equivalent resistance equal to R1 plus R2. So, pag naka-series na siya, applicable na siya for series resistors. And then, for the voltage, so, kani figure 2.30 mo na siyang equivalent circuit given na gikombine na ang duha ka resistor and then gitawag na siya og equivalent resistance or R sub EQ. Going back to figure 2.29, makita natin diri sa figure that naay V sub 1 ang R1, so voltage 1, and then voltage 2 sa R2. To solve that, so going back here, V sub 1 is just equal to voltage times the quantity of R1 divided by R1 plus R2. And V sub 2 equal to R2 over R sub 1 plus R sub 2 times voltage. So, for that given nga circuit sa figure 2.29, mo na siya ang mga equations sa V sub 1 o V sub 2. Mo na siyang pagkuha sa voltages for the resistors. Notice that the source voltage V is divided among the resistors in direct proportion to the resistances. The larger the resistance, the larger the voltage drop. Okay, so the larger the resistance, the larger po ang voltage nga iyang gina-consume ana nga resistor. So, given sa discussion sa Kirchhoff's law, nakaingon dito nga ang total voltage sa load is just equal to the voltage sa source. That's why ingon diri ang source voltage is divide lang dito sa resistors dito sa circuit. So this is called the principle of voltage division. So gi-divide ang voltage. So muna gitawag nga principle of voltage division. And the circuit in figure 2.29 is called a voltage divider. In general, if a voltage divider has n resistors, n meaning R1, R2, or more in series with the source voltage, the nth resistor or Rn will have a voltage drop. Uy, nasumpay. Voltage drop of, so mani hamang sumpayan. Okay, we have a voltage drop divided from the voltage source. Okay, so V sub n, there is a right side. V sub n is just equal to R sub n. So, kung pila ka buok ang, or kung sa itong resistor, ang pangitao ng voltage, divided by the total voltages, the total resistances sa series circuit times voltage. So, therefore, pag nakaseries ang mga resistors, ang R equivalent anak nila is i-total lang ang kada isa nga resistances. And then, kung kaon ang voltage sa specific nga resistor, mahimo na siyang kaning Rn, mo na ibutang nimo diha ang value. Kung pila tong resistance sa resistor nga gusto nimo pangitaon ang voltage, mo na ibutang nimo nga value sa Rn divided by R equivalent. So kaning denominator R equivalent multiplied by the voltage or voltage source. Then, the equivalent resistance of any number of resistors connected in series is the sum of the individual resistances. So, matang giingon, ang equivalent resistance lang is ang total lang ng resistances nga naka-series. So, mo siyang R equivalent for series resistors lang na siya. So, for n resistors in series, then, so mo na equation niya na form R equivalent or equivalent resistances is equal to R1 plus R2 plus ... plus Rn. Resistors in series behave as a single resistor whose resistance is equal to the sum of the resistances of the individual resistors. Okay, so that's for the series resistors and voltage division. And now, let's go to parallel resistors and current division. Consider the voltage in figure 2.31. So, two resistors in parallel, where two resistors are connected in parallel and therefore have the same voltage across them. Okay, so pag ang resistors gani naka-series, tanan resistors have the same current flowing through them. But if ang resistors naka-parallel, they have the same voltages along the resistors. So, mo na siya ang kalayan sa series resistors and parallel resistors. Okay. So, from Ohm's law, so ang voltage V will be just equal to I sub 1. So, current 1 nga nag-flow sa R1. So, current 1 times resistance 1 is just also equal to current 2 or I sub 2 R multiplied by 2R sub 2. So, since parallel ang resistor and then nakaparallel po sila dito sa voltage source, meaning they have the same voltages. Kung pila ang value anang voltage source, mao pod ang voltage anang R1, mao pod ang voltage anang R2. So, ang different lang, lahi ang current nga naga-flow sa, lahi ang value ng current nga naga-flow sa R1, o lahi pod ang value sa current nga nag-flow sa R2. So, for the given equation from Ohm's law, so current 1 will be just equal to voltage source divided by R1, and I sub 2 is equal to voltage divided by R2. Therefore, current I will be just equal to I sub 1 plus I sub 2. So, ang current gikan sa source is na-divide dito sa R1 o sa R2. Muna gitawag nga current division. Okay, so naaman diri ang Sa ikaduhang formula, formula ng I1, formula ng I2. And then, formula ng current, total current. So, substituting the formula of I sub 1, which is V over R1, so, muna siya. So, I, current, equal to voltage divide R1 plus voltage divide R2 equal to, so, simplify voltage times the quantity of 1 over R1 plus 1 over R2 equal to voltage divided by R equivalent. Okay, kani nga equivalent resistance is different ang formula niya sa parallel o sa series. Kung naka-series, i-total lang directly kung pila ang resistances. But if naka-parallel, kung naka-parallel ang resistors, the equation would be 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So, ang R equivalent, mao ni siya ang formula 1 over R1 plus 1 over R2. So, different so, mao ni siya. Different ang formula sa series resistors o sa parallel resistors. So, mao ni ang equation in getting the equivalent resistance if naka-parallel connection ang mga resistors. So, R equivalent equal to R1 times R2 divided by R1 plus R2. The equivalent resistance of two parallel resistors is equal to the product of their resistances divided by their sum. In the general case of a circuit with n resistors in parallel, the equivalent resistances is, so mo ni siya ang general equation yun. Kung daghan na ang resistance nga resistor nga nakaparallel, so mo lang ni siya ang equation. 1 over R equivalent equal to 1 over R1 plus 1 over R2 plus plus 1 over R1. So, 1 over resistance total. So, mo na siya ang equivalent resistances for parallel resistors. It is often more convenient to use conductance rather than resistance when dealing the resistors in parallel. So, it is discussed in chapter 1 sa basic concepts that ang reciprocal ng resistor is what we call conductance. So, if ang resistor is R1, ang conductance will be 1 over R. So, kung mangita sa equivalent resistance nga nakaparallel connection, it is better to use conductance because gamiton man ang value sa tong 1 over R. So, mahimo siyang whole number. Dili na siya fraction. So, equivalent conductance will just be equal to conductance 1 plus conductance 2 plus conductance 3 plus plus conductance n. Okay, knowing that conductance is just equal to the reciprocal of resistance rather. The equivalent conductance of resistors connected in parallel is the sum of their individual conductances. Equivalent circuit to figure, okay. So, figure 2.32, muna na siyang equivalent circuit. Kung nakaparallel siya, kung pila itong makuha ni mga conductance, muna to ang R equivalent. So, easier gamiton ang conductance when getting the equivalent resistance with the resistors nga nakaparallel in connection. Okay, so mo ni ang general equation. Okay, this equation which shows that the total current I is shared by the resistors in inverse proportion to the resistances. This is known as the principle of current division And the circuit in figure 2.31 is known as current divider. 2.31. Okay, so muna siya ang gitawag nga current divider. Kani siyang figure 2.31. Current divider siya since lahi ang current nga nag-flow sa R1 and lahi ang current nga nag-flow sa R2. Pag i-total na siya ang I1 plus I2, muna siya ang total current or kaning naka-I. Okay. So, there is a figure 2.33 sa A. So, kung shorted circuit, ang current nga naga-flow diri sa resistor, no? So, ang isa is shorted, kaning R sub 2. So, R sub 2 equal to 0. R sub 1 na i-value. So, ang I sub 1 will be equal to 0. Manuman, pag naka-shorted siya, pag short circuit siya, ang current mo flow tanan dito sa naka-short nga connection. Since ang R sub 2 equal to 0, meaning ang maximum current moagi diri sa R sub 2 which is equal to ang resistance will be equal to 0. And then ang I sub 2 will be equal to I. So ang mag-agi diri sa R1 mahimo ng 0. Letter B, an open circuit. So, manang kalahian ha sa current kung shorted circuit o sa current in an open circuit. Kung open circuit po, parehas sa aning sa figure B, open circuit siya pag ang resistance niya is approaching infinity, meaning dako kaayo ang value sa R sub 2. Pag dako kaayo ang value sa R sub 2, current will be equal to 0. Meaning I sub 2 equal to 0. Therefore, ang current nga mo flow tuatanan sa R1. So, walay current nga nag-flow diri sa R sub 2. But it doesn't mean nga 0 po yung voltage. 0 yung current, but naay voltahe aning open circuit. Same po diri sa shorted circuit, naay-value ang current diri sa R sub 2, naay-value I sub 2 equal to I. Pero ang voltage niya diri is equal to 0. Is equal to 0 na siya diri Okay, let's proceed. As an extreme case, suppose one of the resistors in figure 2.31 is 0. Says R sub 2 equal to 0. So, muna siya explanation sa kuan ganina figure. So, you just read it. Okay, example 2.9. Find the equivalent resistance for the circuit shown in figure 2.34. Okay, example 2.9. So, nakamix na ay series, na ay parallel. Ang series nakaparallel sa another na po nga resistors. Okay. If inani gani nga pangitaon ang equivalent resistance, mag-start ka sa pinaka-outer. Asa man ang pinaka-outer? Diri sa 5. Okay, looking at the figure, ang 1 ohm is just connected in series sa 5 ohms. So, connected siya in series. So, pwede nimo siya i-total directly. Meaning, kani nga duha ka resistor, ang equivalent resistance niya is 6 ohms. So, muna siya. And then, kani pong 3 ohms and 6 ohms, nakaparallel na silang duha. Meaning, pwede na siya i-solve using the parallel equivalent resistance na formula, which is 1 over 3 plus 1 over 6, or using the conductance. Ano naman ito? Arrow. Okay, let's proceed to the solution. Okay, so solution. Okay, so kanina, discuss na ko ang 1 ohm. So kanina, ang 1 ohm is in series to 5 ohms. So, mauni siya ang 6 ohms. Series. Wala na ako napakita ang pag-solve sa 6 ohms. So, since series siya, i-total na nimo siya 6. And then, kaning 3 ohms and 6 ohms, using the equivalent resistance formula sa parallel resistor, so ang makuha is 1 over 3. So, kung solve, 1 over 3 plus 1 over 6 equal to 1 over R equivalent. Okay. Two plus 1 equal to 1 over R equivalent. Sa aha, kay solve pa na ko. 1/2 equal to 1 over. Okay, so R equivalent. So, equivalent resistance aning 3 in parallel to 6 is just equal to 2 ohms. Namre, dari. Kapang gisolve. 2 ohms. And then, 1 ohm plus 5 ohms equal to 6 ohm. Namre, dari Abi na ko na sulat. So, muna siya ang solution atong naka-series o naka-parallel. So, kaning 1 ohm plus 5 ohm naka-series. Kaning 6 ohm o 3 ohm naka-parallel. So, muna siya ang equivalent nga circuit na. Given nga kanina, himo ng equivalent resistance sa 1 and 5, kani sa 3 and 6. So, karon ang 2 ohms ug ang sa ka 2 ohms, duha ka 2 ohms naka-series. I-total na siya. So, 2 ohm plus 2 ohm equal to 4 ohms. So, nakuha na. So, 4 ohms. 4 ohms in parallel, kani 4 ohms in parallel with 6 ohms. So, 4 ohms in parallel with 6 ohm equal to 4 times 6 over 4 plus 6 equal to 2.4 ohms. Okay, so 2.4 mo na ni. 2.4. So, ang nabilin na lang, 4 ohms, 2.4 ohms, and then 8 ohms, which is naka-series na. So, since naka-series na siya tanan, pwede na siya i-total directly. So, equivalent resistance equal to 4 ohm plus 2.4 ohm plus 8 ohm equal to 14.4 ohms. So, therefore, ang equivalent resistance ani nga circuit, equivalent resistance is 14.4 ohms. Okay, practice problem for you to answer. Okay, so given na ang answer 6 ohms, I hope nga isolve ninyo ni para ma-practice mo. Anyway, gidiscuss mo guro ni sa okay. So, na may guide ninyo na sa PDF. So, gidiscuss naman ako ang isa ka example and then use the equations given. So, sa equivalent sa series resistors, i-total lang ang value ng mga resistance. Pag parallel resistors, ang equivalent resistance ana will be 1 over R equivalent equal to 1 over unang nga resistance plus 1 over R ikaduhang resistance plus 1 over katulong nga resistance, so on and so forth. So, pila ka resistors ang nakaparallel. So, answer is 6 ohms. So, try solving this for your practice. And then, ang answer ninyo, ibutang dito sa site. Kay murag, appeal ni siya sa inyong practice problem which is to be submitted on the site. Okay, how about this? Calculate the equivalent resistance RAB in the circuit in figure 2.37. Okay, let's go directly to the solution. Okay, balik na diri sa figure 2.37. Nakabutang diri nga ang point B, so naay tulo ka B, 1, 2, 3 nga point B. Pasabot ana, isa lang na siya ka node. Isa lang na siya ka node. Sa ato pa, kaning 12 ohms, nakaparallel ni siya sa 4 ohms. And then, kaning 1 ohm o 5 ohm naka-series. So, let's go to the solution. Okay. So, to. Okay. Let's go to the solution. Muna ang solution. Ano to? Wala na solve. ang 4 ohms nakaparallel sa 12 ohms. So, kung nakasolve ba ni? So, 12 ohms nakaparallel sa 4 ohms. So, ang equivalent nga resistance antong duha 3 ohms. So, mao ning nakabutang diri ang 3 ohms. And then katong 1 ohm plus 1 ohm plus nakaseries nga 1 ohm ug 5 ohms, 6 ohms. Mao nasa kilid, nakakilid. And then so mo na to siya ang simplify so far. Kani 12 ohms, 4 ohms, 1 ohms, and then 5 ohms. And then 2 ohms in parallel with 2 ohms in parallel with 3 ohms. Okay. 2 ohms in parallel with 3 ohms. Okay, asa man tong 2 ohms gikan. Okay, ang 2 ohms gikan na siya sa 3 ohms and then 6 ohms nga nakaparallel pod. So, balik ko na ko. Ang kaning 12 ohms o 4 ohms nakaparallel. Kaya kung tanaw na to ang circuit, isa ra ka node ning na ay B nga nakabutang. So, node B. Node B, isa ra na siya ka node. Therefore, 4 ohms and 12 ohms is in parallel connection. And then, 6 ohms and 3 ohms is in parallel connection. So, ang equivalent anang 3 ohms and 6 ohms, 2 ohms. Ang equivalent anang 4 ohms and 12 ohms, 3 ohms. Okay, so mo ni siya ang equivalent circuit. And then, so mo ni siya ang equivalent circuit. So, 3 ohms and 6 ohms in parallel. So, equivalent nila is 2 ohms. So, 2 ohms plus 1 ohm. 2 ohm plus 1 ohm, 3 ohms. So, 3 ohms in parallel with 2 ohms, morning 1.2 ohms. Okay, so 1.2 ohms. 1.2 ohms, so kanin mo ni siya, 2 ohms in parallel with 3 ohms. Equivalent nila is 1.2 ohms. So, nakaseries na. Pag makuha ang value ani, in series dayon sa 10 ohms. So, 10 plus 1.2 equal to 11.2 ohms. So, ang equivalent resistance, which is the RAB, is just equal to 11.2 ohms. Okay, let's proceed. Okay, another practice problem for you to solve. The answer is 11 ohms. Okay, example 2.11. Find the equivalent conductance equivalent conductance for the circuit in figure 2.40. Okay. So, ang given circuit, so 8 Siemens in parallel with 12 Siemens. Oh. So, nakaparallel siya. And then, ang parallel connection nga 8 and 12 Siemens, nakaseries sa 5 Siemens. And then, nakaparallel na po sa 6 Siemens. Okay, let's go to the solution. Okay, 8 Siemens plus 12 Siemens equal to 20 Siemens. So, 20. And then, nakaseries siya sa 5 Siemens. Sa conductance, baliktad ang iyahang equation sa resistances. Pag nakaseries gani, balihon. So, 5 Siemens in series with 20 Siemens. So, answer is 4 Siemens. Ang 4 Siemens nakaparallel sa 6 Siemens. So, total na siya. So, ang answer is 10 Siemens. So, equivalent conductance is 10 Siemens. Okay, so ang question na to, equivalent. Okay, nakuha ng answer, 10 Siemens. Okay, there is also another solution using resistances. Kung i-convert nimo into resistance ang value ng mga conductance sa circuit. So, if imo i-convert, mag-deal na ka sa mga fraction. Dili na whole number imong gamiton, mga fraction na. So, medyo maglibog mo. But anyway, it's up to you. As long as you have the correct solution with the correct answer. Another practice problem. Another example. Example 2.12. Find current I.O. and voltage V sub O in the circuit shown in figure 2.42. So, pangitaan ang value ng I sub O and V sub O. So, that is the current and the voltage in the 3 ohm resistor. Calculate the power dissipated in the 3 ohm resistor. Okay, so tulo ang gipangita. Ang current, ang voltage, ug ang power nag-consume sa 3 ohm resistor. Okay. So, 3 ohms is in parallel with 6 ohms, so that is 2 ohms. Okay, mo na equation ang solution. 2 ohms is equivalent. So, mahimo na siyang 2 ohms. So, gibutang diri ang VO. Since nakaparallel ang 6 ohms ug ang 3 ohms, pasabot ana, they have the same voltages. That's why, in the figure 2.42b, naagihapon ang V sub O. Kay same naman sila ang voltages. Bisag naka-equivalent resistance na siya. So, ang 2 ohms, naka-series in connection na sa 4 ohms. So, therefore, iyahang equivalent resistance for the whole circuit is 6 ohms. Okay. With the equivalent resistance ng 6 ohms, makuha na ang value sa current I. Okay. Current I. So, I is just equal to voltage divided by resistance. So, ang voltage, so current I equal to voltage, 12 volts, divided by equivalent resistance. So, that is 4 plus 2 ohms. So, the answer is 2 ampere. So, ang value aning current, gikan sa source, nga nag-supply sa tibok, load, is 2 ampere. Meaning, kaning 2 ampere, mo na nakasubdivide nga current dito sa tibuok ng mga load. Sa tulo ka resistor. So, going back, pilang value daw sa V sub O? So, V sub O is just equal to 2. So kung sa discuss ganina, kung unsang resistor ang gipangitaan og voltage, mo na ibutang dali sa taas. So, 2 ohm divide equivalent resistance, 2 plus 4 ohms, times the voltage, 12 volt. So, voltage VO, V sub O, is just equal to 4 volts. Okay, 4 volts. Meaning, 4 volts pod ang, so balik na rin yung figure A, kung 4 volts ang VO, meaning, makuha na ang value ng I sub O. Unsa pa ganito ang formula sa current? Current is equal to voltage divided by resistance. Okay. So current I sub O is just equal to 4. Okay. So, nakuha mo to kayo na, no? 4 ang voltage sa V sub O. So, V sub O equal to 3, I sub O equal to 4. So, gipangita man ang VO. So, I sub O is just equal to 4 over 3 ampere. So, gamit ni nga equation. So, divide both sides by 3. So, current I sub O is just equal to 4 over 3 ampere. Okay. The power dissipated, so mo na nang gipangita kani nga answer. So, napay isa ka solution. So, you study this. So, there's daghay pamagi para makita ang I sub O. So, kani siya ang pinaka-simple. So, anyway, musta akong giingon, sa unsa pa imong solution, basta kay sakto ang solution, makakuha jud kag saktong answer. Okay. Ang katingalahan lang, kung sakto imong answer, pero mali imong solution, wala gihapon kay points. So, you better study and practice solving. Okay, the power dissipated in the 3 ohm resistor is, okay, power, formula ng power is equal to voltage times current. So, ang voltage, 4 ohms, 4 volts rather. Voltage is 4 volts, current is 4 over 3 volts. So, 4 times 4 over 3 equal to 5.333 watts or 5.3 watts. Okay, so nakuha ng answer na ang voltage nakuha na 4, current is 4 over 3 ampere, and power is 5.3 watts. Okay, another practice problem for you to solve. Another example, example 2.13. For the circuit shown in figure 2.44, A, determine the voltage V sub O. V sub O, haman ang V sub O eh. Ang voltage V sub O. Ano may V sub O? Okay. Matugikan. The power supplied by the current source and the power absorbed by each resistance. Okay, for this figure of example 2.13, okay, kamo na lang ang mag-study ani sa PDF, just study and practice solving. Naman ito ang solution. Just follow and sabta ang giun sa pag-solve, sabta giun sa pag-manipulate ang mga formulas para ma-familiarize mo sa pag-solve. Okay. Another practice problem. And that's all for series resistors and parallel resistors and voltage division and current division. Okay, I hope you understand. That's all.